Hello there. Today we'll be looking into how to solve matrix multiplication and obtain the resultant matrix. There are numerous mathematical conventions on how to solve given matrices, to find their matrix multiplication product, but in this video I'm going to be talking about the most simplest method and the common or rather widely accepted method. So for the case of simplicity, I'm going to be taking a simple 2 by 2 matrix to multiply with it with another 2 by 2 matrix. So let's say 1, -1, 3, 2, and second matrix 2, 1, 3, -2, and the resultant matrix. So we'll be essentially multiplying this matrix 1 with matrix 2 to obtain the resultant matrix. Yeah, so before we proceed further, one important thing to know is that how to find the dot product of given two ordered pairs. So regarding that, let's say we're given two ordered pairs 2, 1 and 3, 2. So how we're gonna find the resultant dot product of these two given ordered pairs is that you have to multiply the corresponding entries of the two ordered pairs and then you have to sum it. So 2 times 3 is 6 and then 2 times 1 is 2. So this is going to be 8. So similarly, what we're going to be doing to the matrix is that we're going to be multiplying the ith row of the first matrix with the jth column of the second matrix to obtain the ijth entry of the resultant matrix. Let me write that down. So ith row of matrix 1 dot product jth column of matrix 2 would give you the ijth element of resultant matrix. So we'll proceed with that. So what are the ordered pairs now? 1 and -1 dot product 2 and 3. This is going to be 2 times 1, which is 2, and 3 times -1, which is -3. This is going to be -1, -1. So the first entry, or rather this is the first row, right, and this is the first column. So the ijth element, that is the first row first column element of the resultant matrix, is -1. Similarly, we are going to be multiplying the ith row of the first matrix with the second column of the second matrix to obtain the first row second column of the resultant matrix. So this is the first row again, but this is the second column. So element 1, 2 is first row and second column, and that is going to be this element right here. So we are now going to find the dot product of 1 minus 1, this ordered pair, and 1 minus 2. This is going to be 1 and plus 2, which is going to be 3. So this element here, right here, is going to be 3. And similarly, the element here would be obtained by finding the dot product of the ordered pair produced by the second row and the first column. Let me just clear up some space here. Yeah, so let's see, 3, 2 dot product 2, 3. 3 times 2 is 6, added to 3 times 2 again, 6, which is 12. So this element right here is going to be 12. And this position is given by second row, second column, right? this element right here is second row of the resultant matrix and second column. So we're essentially going to be multiplying or rather finding the dot product of the ordered pair obtained by the second row of the first matrix with the second column of the second matrix, which is going to be 3 comma 2 dot product 1 comma minus 2, which is 3 minus 4, which is negative 1. So this element right here is negative 1. And here it is. This is the simple way to find the matrix multiplication of two given matrices. And one more thing to remember is that you might be given different order matrices and might be fine to the resultant matrix multiplication. But the thing that you have to remember is that you can only find the matrix multiplication of two given matrices if their orders are appropriate. In the sense, the order of the first matrix here is 2 by 2 and order of second matrix here is 2 by 2. So we're going to be checking this order right here of the first matrix and the first order here of the second matrix. If they are equal, only then we can find the resultant matrix multiplication. Suppose we're given a matrix of this order, let's say 1 2 3 matrix here, and then another matrix of this order. The order of first matrix is 1 row 3 columns. Second matrix order is 3 rows 2 columns. If you check this out, the orders are the same, so you can actually find the matrix multiplication product of this matrix. Let's say another set of matrices. This, let's say, is 1 2 3, and let's say this is 2 2 4. Okay, the order of the first matrix here is 1 row 3 columns, and the one right here is 2 rows 2 columns. Here these two respective orders are not equal, so we cannot essentially be multiplying them. So that is another thing that we have to remember, and that's it. Good to go.